Okay, I'm back. I'm going to do a powder lab with you on identifying ionics versus covalents. And from there, the covalents, we're going to identify them further as either polar or non-polar covalent. So here are our powders. So here's A, and we're just going to look at A in here. I can get this going. Okay, so hard to see, I know. So much better if we were in person, but we're just gonna do it this way. Here is B, okay? And B is a little bit more fine. Here is C, okay? So here is C. And when you look at C, again, just notice, are they granules? Are they chunks? Okay, here we go back to all of them. There's more of a powder. They're all white and solid, so that's one observation you can write down. And then here's D, and take a look at D. Okay, kind of interesting. Okay, and you can get 4 before observations. Okay, we're going to figure out the identities of these white powders. So again, ionic or covalent, and if covalent, polar or non-polar. So let's do a solubility test. So we've got 4 empty beakers here, and for the sake of time, I've got my water already filled or measured into my graduated cylinders, and just the angle of the camera. So you can see there that the bottom of the meniscus of the liquid is lined up at the 25 mil mark. Okay, not as easy to see here on camera. And I'm going to add the water, and then we're just going to add a small amount of powder. So just sort of the tip of the scapula, and we're going to add that in, and then we will stir that up in a bit. So I'm just going to keep on going down the line, adding my water, adding a small amount of powder. Here's C. And just a note about the water that we're using is deionized water. Deionized water has been filtered so that there are no ions in it, just like it says. And we want that because we don't want any false tests. Now, this one's going to be harder to get. Let me see what I can do here with one hand. I might have to sprinkle a little bit in here. This one's a little bit tougher. Okay. And then we're going to give these a little bit of a stir or a swirl and see if they will dissolve. Okay, so just go around, swirl it. It's not looking like it's dissolving. We don't see anything there. Those shards are not looking like they're dissolving. I'm going to go back to this one. And that one, poke at it. That one is dissolving. It's just that there's a bit of a clump. But we can see that that's dissolving. Okay, so we can look at those solubility tests, and we can see that that's dissolving. It's not fully dissolved, but if we waited another minute or so, we're going to see that that's going to totally dissolve. Okay, this here, cloudy, means that the particles are suspended. They are not dissolving. Here's C again. I don't see anything. And there's D, okay, so those crazy crystals. And they are floating on the top. Let's do a conductivity test next to see what happens there. We're going to do a conductivity test now to see if there are ions dissolved. If there's ions dissolved, then we will conduct a current. These testers are a bit different. The light comes on red if it's not conducting a current. Okay, so we'll put this in A. Again, this is sample A. Light is on, indicating no current is being conducted. Here's B again. B did not dissolve. light is on. Okay, actually weak. It's not as strong of a red color as the previous one. So that tells us that maybe it is conducting slightly, but not a lot. Okay, otherwise there'd be no light. Here we go again. Okay, so this is C. We're in. No light, no red light, meaning that it is conducting electricity. Okay, C is conducting. Here we go with D. Didn't even dissolve, so I think we can kind of guess what's going to happen here. And again, light is on, indicating that it's not conducting electricity. We're going to do a melting point test now. And what we'll do is, again, we took the tip of the scupula of each of our samples. You can see there's A in there. There's B in there. Okay, there's B. Here's C. And then here's D. You can see them in there. They are definitely in there. Okay, we're going to put them on the hot plate all at the same time. So we're going to crank the hot plate up to, let's go to 8. And let's put A, there's A, folks. Let's do B this way. Let's do C. And let's do D, okay? And all of them are 2-ply. I'm just making sure that it's heating up. Go up to 10 here. Here it goes, I can feel it's getting hot. And so what we do is we put them all on at the same time. We put them all on a cold hot plate so that they'll all heat up the same time, same rate. And we just start to watch. Yeah, I can feel the heat. We just start to watch for a sign of melting. Now, we can't really, state what the exact melting point is going to be in a temperature because we don't have a thermometer and we're not going to measure that way. So just remember it was A, B, C, A, B, C, D, okay? A, B, C, D. And we're just going to, oh, this one's already gone. The D is gone, okay? Nothing is left in there. Okay, D is gone. So that's telling us a low melting point for sure. Totally gone, evaporated. Now we'll wait for the others. So I'm actually going to take that one off because there's just no value in it. Again, there's nothing in there anymore. So we're going to wait on the other 3. And all that we can really do is just say, high or low melting point. So obviously D has a low melting point. Here's A, B, and C. And we'll just wait to see if we get any action here. We'll wait about 3 or 4 minutes. That's it. So it's a bit of a boring test. Oh, and I think we're starting to see something right there. It's liquefying. Okay, so A is starting to liquefy. So that's telling us, again, a lower melting point. Yeah, you can see what's happening there. Okay, so we got melting happening with A. Okay, and I'm just going to take that off. And then we'll wait on B and C a little bit longer. But we do expect some of these to be ionics, and if they are, then they have a high melting point. We shouldn't see anything. You might remember from my lesson that salt has a melting point of 800 degrees C. This is very hot. The hot plate cannot get that high. So let's go to 3.5 minutes here, and I'm seeing no changes whatsoever with these powders. Okay, nothing is happening. So there we are, 3.5 minutes. B and C have not melted.